Hello everyone, I'm Lao Gao, and today we're going to talk about the movie planets. As you all know, our solar system has 8 major planets, and at one point there was Pluto. However, Pluto was demoted in 2006, so now the solar system consists of 8 major planets. But in recent years, there has been a rumor that there is an invisible Earth in the solar system, a quite large planet, but you can't see it. We know it exists because, even though it's invisible, it impacts other planets. There's a huge object orbiting in the solar system, pulling on other planets, but we can't find it. If it does exist, it might change our view of the solar system quickly. Astronomers have long thought our knowledge of the solar system was thorough. It's quite thorough, right? Since we're in the solar system, it's closer to us, but I didn't expect such a big thing here that I missed. Sometimes what I find can't be called a complete discovery. However, various signs now indicate it really exists. Yes, it's invisible. However, based on current predictions, its form might be capable of supporting life. So many teams of astronomers are actively searching for it now. So, this 9th planet, indeed it is. So, the topic of this 9th planet, we have to start from 180 years ago. In 1846, humans discovered Neptune, which was the first planet predicted to exist through calculations. After all, before the 18th century, human observation technology was very limited, and it was impossible to directly see Neptune. However, based on the position of Uranus and the orbital calculations of all the planets within Uranus, they discovered there was definitely a planet out there, and sure enough, in 1846 it was found. After discovering Neptune, calculations of Neptune and Uranus's orbits revealed something strange about their paths, suggesting there might be another planet beyond them. Also, this star might not be small, and its impact is significant. Consequently, over 80 years later, in 1930, Pluto was found. At that time, the field of astronomy was truly shaken. Finally, based on predictions, another planet was found, but upon seeing Pluto, everyone felt a bit disheartened because Pluto was too small. Its mass is only 1/500th of Earth's and 1/6th of the Moon's, which is vastly different from the previous estimates. It was initially thought to be much larger than Earth, but it turned out to be quite small. However, due to the limitations of observational technology at the time, it was indeed difficult to discover planets beyond Pluto. From that time on, our understanding was that the solar system had 9 planets. This notion persisted until I was in college, but then in 2005, a significant event occurred. Michael Brown, a renowned astronomer from the California Institute of Technology, discovered a small celestial body far beyond Pluto. It's not exactly small, as it's slightly larger than Pluto. It's quite a bit bigger, about the same size. This is what later became known as Eris, which means the goddess of chaos. Why is it called the god of chaos? Well, this celestial body, Eris, is larger than Pluto and also orbits the sun. So if Pluto is considered the 9th planet, then Eris should be the 10th. However, shortly after, several other celestial bodies of similar size to Pluto, or just slightly smaller, were discovered near Eris, and they also orbit the sun. If discoveries like this continue, the solar system would end up having an 11th, 12th, and 13th planet. More and more, so in 2006, which was the following year, the International Astronomical Union redefined the term planet. A new concept was introduced called dwarf planets. Pluto and Eris were categorized as dwarf planets. This ensured that the concept of planets in the solar system remained basically stable, which is the 8 major planets. At that time, it was believed that beyond Pluto, it would be difficult to find a planet of significant size. Indeed, up to now, the largest in mass is this particular celestial body. However, unexpectedly, just 8 years later, in 2014, the renowned American astronomer Scott Shepard, along with another astronomer, Chad Trujillo, discovered some anomalies in the orbits of several small celestial bodies while observing the movement of objects in the Kuiper Belt. The Kuiper Belt, as we have mentioned in previous films about the solar system, is a ring-shaped region beyond Neptune, composed entirely of small frozen celestial bodies. It is somewhat similar to the rings of Saturn, yet instead of encircling a planet, it is a notably large ring revolving around the sun. Within this ring, there exist some frozen celestial bodies, with the largest ones being Sedna and Pluto, whereas the remainder resemble meteoroids and chunks of ice. Theoretically, all the celestial bodies within the Kuiper Belt are expected to orbit the sun in a generally circular path. Nevertheless, they discovered that there are indeed a few stars with elliptical orbits, and these orbits are quite elliptical. It is as if, at a certain point in time, a considerably large star passed by and exerted a gravitational pull on these few stars, drawing them over. Their orbits became elliptical. Judging by the extent of their deviation, the object that passed by must have been quite large, definitely larger than Earth. So at that point, they proposed a hypothesis. Is there a massive planet beyond the Kuiper Belt? This time, it would be a true planet, not a small celestial body like Pluto or Eris. After they proposed this hypothesis, many astronomers wanted to prove whether it might exist or not. The person I mentioned earlier who discovered Eris is the astronomer named Michael Brown. During that time he, due to his discovery of Eris, which subsequently led to Pluto being reclassified as a dwarf planet, earned the nickname Pluto Killer. So Michael Brown has always wanted to find something to make up for this regret. Therefore, he is particularly interested in this matter. Initially, he wanted to prove that this ninth planet might not exist because, according to his understanding, the orbital deviation wasn't caused by any planet. At that time, he was conducting research together with a very young astronomer named Konstantin Batygin. This person was born in 1986, so young, quite impressive. The two of them discovered through simulation calculations that this thing might really exist. According to their calculations, the mass of this ninth planet could be 5 to 10 times that of Earth, which is 5,000 times that of Pluto. So in 2016, they published a paper stating that they had found possible evidence of the ninth planet's existence. This publication caused a sensation in the astronomical community. Why was it such a sensation? Because if this ninth planet truly exists, it indicates that our current understanding of the solar system is incorrect. We have conducted various simulations, all aiming to eventually structure it into the 8-planet system. According to this theory, we simulate the formation process of the solar system, but now you're telling me there's a ninth planet, which means the models I initially developed are invalid. This implies that our current understanding of the solar system is flawed. If this planet is indeed so large, why can't we see it? If it's really 10 times the size of Earth, we can see Pluto or even smaller celestial bodies. So why can't we see this one? It's 5,000 times bigger than Pluto, right? It's a bit strange not to see it. After the media reported this, many people started speculating, wondering if this object is avoiding observation in the solar system. Such a large object that can't be seen, wouldn't you think it's hiding, right? That is to say, it might not be a star because it's always been said to be something else. Right? It doesn't have to be a star. Since it doesn't emit light, you can't see it. There are a few reasons why this celestial body isn't visible. First, it might be too far. Initial calculations show it's about 30 billion kilometers away when closest to the Sun, which is 0.03 light years, or the distance light covers in one day. You might think one day isn't far, but sunlight takes only 3 minutes and 12 seconds to reach Mercury, 6 minutes to Venus, 8 minutes and 18 seconds to Earth, and 12 minutes and 39 seconds to Mars. Reaching Jupiter takes 43 minutes. For Saturn, it's 1 hour and 19 minutes. It takes 2 hours and 47 minutes to reach Uranus, and 4 hours to reach Neptune, while it is more than a day away from the Sun, meaning it is 6 times farther out than Neptune, and this is when it is closest to the Sun. When it's farthest from the Sun, it might be 180 billion kilometers away, the same as the time light takes to circle once. Its size could be slightly smaller than Neptune, making observation difficult. Just saying the distance doesn't show how hard it is to observe. It's like trying to see a fly 30 kilometers away from where you are, even with a telescope or anything else. Observing a fly 30 kilometers away from your current location.
It's so hard, it seems impossible to see.
Yes, no matter what you use to observe, I can tell you there's a fly 30 kilometers away. You should make an effort to determine if you are capable of locating it. Another reason it is quite challenging to observe is that if it truly is a fly, it simply needs to move. In theory, we should detect it, but calculations show its revolution was initially estimated with an orbital period between 10 to 20,000 years, meaning it takes that long to orbit the Sun once, which is too slow. It's like a motionless fly, making it very hard to detect, as it blends into the background. You can't tell which is the fly and which is the background. Later, after precise calculations, it was found that its period might be shorter, around 7,400 years, but that's still too slow. Another issue is that it follows an elliptical orbit, with a perihelion and an aphelion, and it might currently be at the aphelion. At the aphelion, firstly, the distance is greater, and secondly, the planet, when orbiting in this elliptical path, moves faster at the perihelion and slower at the aphelion. So now it's distant and sluggish, making it tough.
Discovering it is great, but how long to wait? 1,000 years?
If its cycle is over 7,000 years, and you wait for about 3,000 years, it will come back near the Sun, and you might be able to observe it. However, among these numerous difficulties, there is another factor that makes it hard to observe. The location of this celestial object and the plane of the Milky Way galaxy align on the identical plane. It is concealed by the illumination of numerous stars. It itself is not bright and is particularly dim, being far from the Sun and surrounded by many large stars. It's nestled in the gaps between these stars, making it very difficult to find. Although this Earth-like planet is hard to locate, astronomers still hope to find it as soon as possible because it holds great significance for us. Especially its possible appearance is crucial to us. What it looks like is very important to us. At present, it is hypothesized that there exist various potential forms it might assume. The initial possibility is that it is a terrestrial planet, similar to Earth, which would classify it as a super-Earth. Indeed, precisely, it is referred to as a super-Earth. We have consistently been on the quest for super-Earths in other galaxies, and we did not anticipate there could potentially be one within our own solar system. Why do we need to find a super-Earth? It's because a super-Earth is very likely to have life. It meets the conditions for life even better than Earth, like life forms similar to us, right? Yes, but it's so far from the Sun.
The light can't even reach there. Can there be life forms like us?
Sound? Well, there's still a possibility, you know. It's always been believed that light is essential for life to exist. It's been like this all along, especially for us living organisms on the surface. That's the feeling because we rely on photosynthesis. In recent years, organisms have been continuously discovered in the deep sea, especially around deep sea volcanic vents or on the fissures in the Earth's crust. Basically, wherever there is geothermal energy, organisms can be found. These organisms live in places completely devoid of light, and they do not rely on photosynthesis. Instead, they depend on chemical reactions to produce nutrients, which they then absorb. As for this ninth planet, given its distance from the sun, the possibility of it having no light is indeed there. It could be particularly dark, almost completely shrouded in darkness. However, this doesn't stop them from possibly developing life, as they might produce nutrients through chemical reactions, right? What's key? It's the temperature. If it possesses the capability to have tectonic activity similar to Earth with a hot core and some magma or something akin to it, then it might potentially generate temperatures that are suitable for the emergence of life, and that wouldn't pose a problem. In truth, we don't precisely understand how life on Earth originated. Initially, Earth might have been a young planet brimming with magma. People might assume that such a planet wouldn't harbor any life, but it's not the magma itself. It's that it transported these chemical substances to various parts of Earth, making some regions cooler and others warmer. In 2,000 years, a place might spark life. Key is these chemicals must flow for life to start. And this star, if it's 10 times Earth's weight, it might have a hot core, a super Earth, as some think. With a hot core, there'd be magma, causing tectonic activity, and maybe life. Another point is the common error when seeking extraterrestrial life. We often think if life is like ours, it should be on the surface. But actually, alien life is more likely inside the planet. They should all live on the surface, but actually extraterrestrial life is more likely to live inside the planet. Yes, that's what he said.
So does that mean every planet could potentially have life? Ah, yes.
Actually, it's like this. They just don't live on the surface. They only live inside the planet, right? But living inside the planet makes them hard to find. So in terms of mass, this planet is completely. It meets the conditions for life, however. The possibility of it being a rocky planet is currently considered unlikely. Based on our current observations, rocky planets in the galaxy are generally located near stars. It's a bit far, too far away. So what kind of planet is usually that far? It's called an ice planet, basically an ice ball. From the surface, you can't really tell if it's an ice ball or a rocky planet. The ice isn't necessarily the white, reflective kind that people imagine, especially since it contains impurities like methane and various gases. This kind of ice, under the influence of ultraviolet light, produces a chemical substance called tholin. This particular chemical substance is actually a complex mixture, and this tholin is notably reddish-brown in appearance. Consequently, an ice planet might closely resemble a rocky planet. Pluto serves as an example of this phenomenon. It is often described as an ice planet, yet it seems as though it is enveloped in red rock. It's because the ice contains various impurities, and under the effect of ultraviolet light, it produces chemical substances. Also, the ice on the ice planet might be harder than granite. It's because of these various chemical reactions and impurities, so the so-called ice ball and the ice on our Earth have different compositions. This ice is more complex. As mentioned earlier, it's hard to distinguish from the outside which is an ice ball and which is a rocky planet. On rocky planets, because there is activity within the Earth's crust, there is magma, and there will be volcanoes on the surface that periodically erupt, spewing out magma. As for the ice ball, it has ice inside, and this rolling of water, it occasionally erupts, but it's not a volcano, it's an ice mountain eruption. What erupts is different, that's their distinction. You see, by observing, you can notice it. Rocky planets erupt fire, while ice planets erupt ice. Sigh.
This distinction is hard without eruptions.
If there's no eruption, there might not be a crust, he said, and it would be dead like the moon. The possibility of life existing on such a planet is very small, whether inside or outside. If it's an ice ball, there might be an ocean beneath the ice shell, which is also possible. If it harbors life owing to the existence of an ocean, it is probably because it possesses a heated core, indicating that this seawater might be in motion. This ocean is distinct from Earth's ocean, as it contains a multitude of impurities. So, what is the sensation of this sea? It resembles a chocolate milkshake, a somewhat thick, viscous, and cloudy ocean with exceptionally low visibility. But there might also be life in there.
Life forms like loaches, yes.
Anyway, you know those that don't need visibility, like many deep-sea creatures don't have eyes because they don't need to see? Could this ninth planet be an ice ball? Given our current understanding of the solar system's formation, it's not very likely. Because it's outside the Kuiper belt, there isn't much material there. When the solar system was forming, the closer to the sun, the more material there was, and the farther from the sun, the less material there was. So the 8 major planets are relatively close to the sun, all on one side of the Kuiper belt, while the area outside the Kuiper belt is very far away. How could such a large planet, 10 times the size of Earth, form in a place where it's believed there's so little material? It's not to say it's completely impossible, just that the likelihood is low. So aside from being a rocky planet or an ice ball, another possibility is that it could be a gas planet. Planets like Jupiter, Saturn, Uranus, and Neptune are actually considered gas planets. However, we now classify them as ice giants. The possibility of it being a gas planet is currently considered the greatest. If it is a gas planet, it would be similar to Neptune, but a bit smaller. Neptune's mass is 17 times that of Earth, while it is 10 times that of Earth. However, it might look different from Neptune. As everyone knows, Neptune is a blue planet. Why is it blue? It's because its atmosphere contains methane. Methane reflects light as blue, so the whole thing appears as a blue sphere. However, all of them, Saturn, Jupiter, Uranus, and Neptune, have a problem, which is that their atmospheres are particularly murky. We speculate that although these 4 planets are gas giants, they might have a rocky or metallic core inside. However, due to their extremely dense atmospheres, we cannot see this core, and currently it's all conjecture based on indirect observations. And if this 9th celestial body is a gaseous planet, its outermost atmosphere might be transparent. You can directly observe its second sibling, which remains a particularly peculiar celestial body, a semi-transparent planet.
If there is life inside.
You can see it immediately, but it feels unlike Earth. Earth is rocky with a clear atmosphere above, but this isn't. It has a small yellow river, and outside there's a thick, transparent atmosphere. Why does its atmosphere remain transparent? The reason is that it is a cold gas giant. If it were situated in a warmer region, such as within the Kuiper Belt, its atmosphere would likely become cloudy, akin to Saturn or Jupiter. However, when it is sufficiently distant from the sun, it remains cold, and the impurities or components that might lead to cloudiness condense and descend to the surface. Once the dust finally settles, the entire atmosphere will become completely clear. Furthermore, it will be exceptionally beautiful. It doesn't even have any clouds, and its poles resemble jelly with stunning auroras. Wow, it is a planet that radiates like a luminous light bulb, making it absolutely perfect for tourism, indeed perfect for tourism. It's suitable for observing its core, and this carries significant meaning. We currently speculate that Jupiter and Saturn have cores, but you can't see them even if you send a spacecraft. If you could see it directly, you would know. That's how stars form, and this is their inside look. We haven't seen Earth's core, right? Well, this time we will.
Directly observed it using signals meant for observation indeed.
Its significance is immense, particularly immense, like showing you an exposed starting point. That's why astronomers are divided into many groups, all striving to find it. Of course, to find it, they first have to prove its existence, determine its approximate location, and then use telescopes to observe it day after day, watching for any movement, like spotting a stationary fly. Only when it moves slightly can it be discovered. Now, if this 9th planet is a gas giant, at this moment, there is speculation regarding its formation. It is possible that it was in proximity to Jupiter during the birth of the solar system, not too far away. Consequently, due to its close proximity to Jupiter, Jupiter's gravitational force might have propelled it away, causing it to end up in that distant location. It formed like this. Now, with supercomputers simulating, this possibility exists. Without it, the solar system we know couldn't have formed. That is to say, it formed within the solar system and then was flung out. This theory represents a healthier model of the solar system. However, the premise is to first find it. If it is not found, this model cannot be established. So if it wasn't formed inside the solar system and then ejected, another possibility is that it was captured by the solar system. When the solar system formed 4.6 billion years ago, stars might have been closer than now. Today, Proxima Centauri is the nearest star to us. At that time, the Trisolarans, 43 light years away, might not have been so far, and it's possible that a planet around another star, which could be this 9th planet, approached the solar system and was pulled in to become one of our planets. Well, this possibility does exist. To prove this possibility, we would really need to send a spacecraft up there, collect some samples, and see if there are any elements not found in our solar system. If there are, it would indicate it came from outside. However, at present, we still haven't been able to observe this 9th planet. So there's another hypothesis that this Earth-like planet might not be a planet, instead a micro-black hole. Typically, we think that black holes are formed when a star dies and becomes a black hole, but those are all large black holes. Theoretically, the size of a black hole is not limited. In this universe, there aren't only large black holes, there should be small black holes. How small can they be? These black holes can be as small as the quantum level. This is why when the Celler at the European Nuclear Center conducts this collision experiment, we worry it might destroy the world, because the collision could potentially create a quantum level black hole that could suck us in, right? Theoretically, black holes can be any size, but the smaller they are, the quicker they evaporate, and the shorter their lifespan. So it's entirely possible that there's a small black hole somewhere in our solar system that we don't know about. It doesn't need to be very close to us. Even if it's far away, its strong gravity could still influence the movement of several stars. But you can observe it, you definitely can't see it. If it really is a black hole, then our entire solar system would be in danger. Fortunately, we haven't found one. Finding it would be too terrifying. Lastly, I want to say that if this Earth-like planet really exists, it might also be something we mentioned before. In the mythological narrative of destiny, it is Nibiru, a celestial body that approaches our planet Earth approximately every 3,600 years, and currently it is calculated to be around 7,400 years. However, this is not the definitive answer. It could be that the Anunnaki from Nibiru originated from there, and they established the entire human civilization, which might imply it is our mother star. Finding this ninth planet might be key to solving the Anunnaki mystery.
Is the key to the mystery whether they are still around?
They should be there, and they are much more advanced than us. It is said that this ninth type will be found within the next year or two, or it will never be found. And there is also the possibility that it doesn't exist, as there is a group of people who are trying hard to prove it doesn't exist. So the evidence you have found now is actually observational errors. Some people want to prove that this matter is what Michael Brown referred to as the Pluto killer, and it might be resolved in the next year or two. If it exists, it'll be found. If not, it doesn't exist. There's a chance it doesn't exist. Still, I hope there's one more star, not one less, right? Hope it's not a black hole.